All right. Hello, software engineers. Professor McBurney here. We're going to continue our discussion on design patterns by discussing now creational design patterns. And as we mentioned last time, creational design patterns, taking a look at the slides, are patterns that relate to controlling how objects are created or instantiated. And that's their emphasis. Why would we want to do this? Well, let's start with a common problem. You see, many of you have likely taken 1110, and in 1110 we may have discouraged you from unnecessary use of global variables. In fact, we've probably discouraged you many times from using global variables. Generally, global variables are bad. Why? Well, at this point now, you're familiar with the idea that we want classes with loose coupling. And the loosest coupling involves zero global variables. Data coupling, which is the loosest, is simply, you pass in the arguments you need, those arguments go to the function, it does something, you don't care what, and it returns some data, which you can then use. You have no knowledge of the inner workings of the class you're calling, there's no potential for side effects, etc. When we have global variables, it becomes difficult to use data coupling. We end up with tighter coupled modules, whether those are functions or classes. And so, we generally want to avoid, therefore, using global variables. But the reason we're tempted to use them is because the idea of having a global system state is in fact very valuable. An example of this is in Eclipse. So in Eclipse, I like to use the dark theme myself. It's dark like my soul. It's actually just easier on the eyes, but also yes. But if I want to change the light theme, notice what happens when I change the light theme. Notice how every window didn't update at exactly the same time, right? They were a little bit different. Let's do it again and watch closely, and you'll notice they all kind of happen one after the other, but every window does change. And this is based on the idea that this setting is globally accessible to every window. Every window can be aware of what the setting, what the setting currently is. And so when I change it to dark theme, all of them get updated because they're all monitoring that setting. Which means the settings that are accessed by this window are the same as the settings that are accessed by this window, are the same as the settings accessed by this window, etc. So how do we do that without global variables? We could put global variables in the main program, for example, and have every class access the main program for settings. And then since there's only one main, because that's the thing that's just run, and all the variables presumably would be static, that could work, but then we're getting into a cohesion problem, right? Generally, the main class, the thing that starts it, should have the purpose of in Eclipse, the main class has the purpose of instantiating all the objects and running the program. Now we're saying instantiate all the objects that you need at launch, run the program, and also maintain the settings. That's not cohesive. So the problem that we have, the problem that we need to solve, is that we want to have a class where these settings can be stored, and we want every other class that uses this to share the same instance. Same setting, same theme color, for example. How can we do that? How can we make sure for a class that there's only ever one instance generated? Think about this. Pause the video for a second and see if you can come up with a solution. Go ahead and pause. All right. I'm assuming at this point that you've actually thought about it, but if you haven't, we're still going to give you the solution anyway because this is a video and I can't do a choose your own adventure here. So with that, a design pattern, a solution to this problem, this is an example design pattern, is called the Singleton. And the Singleton is a class that can only have one instance at a time. And the way that we do that is first, we make the constructor private. We make the constructor private so no one outside of the class can ever call it. And then we have a separate static variable. Remember that static, when we're talking about object-oriented, means it belongs to the class, not to any one instance. So we have a static variable that belongs to the class, which contains an instance of the class. And I'll show you this in a second. If the client needs to get the instance of the class, they simply call a getInstance function, which is publicly available. They cannot call the constructor because it was made private. If the class has not been created yet, getInstance instantiates it. If the class has been created already, getInstance simply returns that existing initialized version. And if you've ever worked with something called log4j, which is log4Java, it's a very popular logging program in Java. It actually uses the Singleton design pattern, and logging is actually quite useful for that. And we'll talk about the reasons why in a second. So what does this look like? Well, this is going to look something like in Java. And again, I'm using Java because Java is very, very explicit as a language, whereas Python tends to be very implicit as a language. And while that means Python can do every single thing that Java can do, it very much can. It's just that Java, I think, makes the design pattern easier to see and understand the first time. So we might have something like a class called mySingleton. This contains an instance of that singleton, which when this class is first loaded in, it will instantiate that. It will call the constructor. Notice the constructor is private, meaning no external classes can call it. But what they can call is a static function, mySingleton getInstance. An example of what this can look like in Java, and I'm going to show a lot of Java code here. I want you to know that all of this has been updated. All of this has been uploaded, I should say, to a Google Drive folder, which I've made publicly available for you all to download. You're very welcome to do so. That will be in a description below in this video, as well as on the CS3240 website article for this video, so you can find it there. And the Singleton class I have here contains maybe some string. It doesn't really matter what the string is. It's just worth noting that there is exactly one string, which is not static. This is a field. This belongs to the instance. It also, the class, has a static singleton instance. And this may look a bit weird. The class contains an instance of itself, but it does. From there, we have some private constructor that takes in some initial attribute, and it sets instance, the instance variable, to the instance of the class that I'm creating. From there, I have a singleton. This singleton will check if instance is null. That is, if this instance has not been initialized, then I'm going to say instance equals new singleton. The default string is you haven't set a string yet. And then it returns that instance. If the class has been instantiated, then we skip that if statement, we go straight to the return. From there, this class has a non-static getter method, get the attribute, and it has a setter method, again, non-static. I have a quick little demo here about how, just to show how you would use this, how this would be used. So some client program, and I say client to mean the thing that is using the class that we created. So we created this singleton class. Anything that uses it could be a client. You can't call the constructor. So if I even try to do this, Java won't let me. It won't compile because the constructor is private. However, I can get the instance by calling singleton.getInstance. From there, I can set the string to hello world. And if I print the string, it will say hello world. So let's do that first part. And you'll see it prints hello world. Now, the second thing I do is I create an instance of this other class, another singleton demo. This is a separate class that also gets the instance singleton. This is some separate class that exists outside of this class, which kind of, This class was kind of my main, because notice public static void main. This is a separate class that also, for whatever reason, would need access to this singleton. So I can simply set it by singleton.getInstance. The same method. It doesn't matter what class I'm in, the way I get the instance is exactly the same. I call the static method getInstance. And then from there I can do anything I want with it. So for example, I print the singleton string, that's what causes hello world to print. I change the string to hi mom, and then notice I changed that string to hi mom inside of another singleton demo, but because both of these classes are accessing the same instance, it also changes that string for hi mom. So the point is, there is one instance, and this is the strategy that we use, this is the pattern that we use, to make sure there is only ever one instance. And by doing this, we can put all the global data that we need into, all the global, say, settings data, into a settings singleton. This can also be useful if you want to do things like logging. Logging is when you're running a program, it enables you to help debug the program, because you write statements to a log file, like this function was called with these arguments. This function returned with this value, etc. If you're having debugging issues, logging can help you. You know, client logged into the server at this time. Client performed this action at this time. That way, when the server crashes, you have kind of a backtrace of what was happening before the crash occurred. That can be done with a singleton because logging to a file, setting up a file stream is fairly expensive, so you want to set up as few as you can. And multiple parts of the system, very different parts of the system, may need to use a logger, may need to log to the same file. If you have multiple instances of file writers, that is, things that write files, that doesn't work if they're all trying to write to the same file. You know, operating systems don't allow that. But if you have a singleton that is logging to the file, everyone can just get the instance of that singleton, and the problem is solved. Another scenario, another problem that you may run into is, let's say you have some program that takes in some tabular data from the user. This is a very common thing. You know, obviously, a lot of grading programs do this. So, you know, you can export and import CSV files into Colab, for example. Class roster might be as a CSV or an Excel file or something. But if you want to allow for multiple sources of data, CSV, XML, Excel, like a SQL dump file, this would be a .SQL file that effectively would rebuild the database with just a bunch of insert statements. And if you're not familiar with that, don't worry too much. But if I want to allow, wrong form of accept, sorry. If I want to allow any one of these data types, well, I could do something like, if file name ends in CSV and then have a CSV parser. If file ends in XML and have an XML parser, etc. But this isn't particularly cohesive, and here's why. Some client needs to get data, and it has a file source. It doesn't want to actually do that parsing. We want a separate class to do that parsing. But secondly, if I have a statement like this in the client program, that means the client program has to be aware of all of the table data, or all the table file types that the client can work with. And that means if I were to later add, okay, now we can also do JSON, well then I have to change this client program to also have an else if statement for JSON files. So how can we make it where we can read in inputs from multiple different sources, have those sources be expandable? We can add new file formats, new styles later without needing to modify the client program, and still have the client program be able to create a data reader, something that reads in that tabular data, and create the correct one that reads in the correct, you know, CSV format, XML format, whatever, without needing the client to change. How can we do this? Well, This is where the factory pattern comes in, and I should note there's a factory pattern which we're going to talk about. There's also something called an abstract factory, which is very different and much harder to describe. Just understand, if you ever see abstract factory, that is a different pattern, and it's actually rather different from what I'm about to show. The idea here is that we define a single interface. For example, we call it data reader or whatever we want, and it reads in tabular data and it returns maybe a list of objects or a hash map or whatever you want. We'll say a list of objects for now. We can define that in the abstract, define an abstract class data reader, and then we can have several concrete implementations like XML data reader, XLSX data reader, CSV reader, JSON data reader, etc. And then the client, rather than calling or instantiating these directly, will use a separate thing called a factory, such as a data reader factory. And this will have a function like getDataReader, string file name, and inside of this class is where we will put things like if file ends in CSV, return new CSV reader. If file ends in .xml, return new XML or data reader, XML data reader, etc. So for an example of a factory method design pattern, let's consider something that I've used this metaphor before. A program that is going to count the number of tweets. Just get the number of tweets in a file. Not looking at states or anything like that. For now, just take in some data, take in some file like tweets.csv, and find how many tweets are in that file. Well, how could we do that if we want to allow for CSV or XLSX or any number of other files? Well, we would simply implement, for example, something like CSV tweet reader, and this is a stub for now. I don't actually have code that reads in a CSV, but you could write that. And I also have a class XLSX tweet reader, but I don't want the client to have to pick which of these they need, because as I add file types, if the client needs to be aware of, as I add reader types, as I add new classes, if the client needs to be aware of all of them, that means as my program ages, it will become more complex on the client class that needs to use this reader to pick the right one. So instead, I define an abstract tweet reader class, defines a method called read. This returns a list of tweets. Just get the list of tweets from this class. And as far as the client is concerned, this is the only class that exists. Now, it is abstract. It's not implemented. This is intentionally not a stub. The method is abstract. It would be implemented by CSV tweet reader and by XLSX tweet reader. This class is used by tweet counter, but tweet counter never directly instantiates the number of, or the type, I should say, of the tweet reader used. It never says XLSX tweet reader, CSV tweet reader. In fact, this class is completely unaware that those other classes even exist. And the reason is we have a tweet reader factory, and the factory method, which is kind of the key crux of the factory design pattern, is it takes in the file name. If the file ends in CSV, it returns a new CSV tweet reader. If the file ends in XLSX, it returns a new XLSX reader. And from there, if I were to add a JSON, well, I could just simply say, else if file name dot ends with JSON. And then I could return a new JSON reader. And I could simply have all that handled inside of the factory class, which the client only needs to know how to use. That is, the client says, I give this class a file name. It gives me the right reader. However, that's done. From there, tweet counter creates an instance of this factory. it gets a reader from that factory by saying, okay, here's the file name, give me the right reader. And the factory will give you the right one, and you don't have to worry about it. And then all you need to do is call that read function, call the abstract function that you need, and the factory's made sure that that directs you to the right type of reader that you need. So this code, again, uploaded. See the description below, or see the lecture video article on the website for that. You can download it and give it a look. Currently, this doesn't do anything. In fact, I think it actually just runs a null pointer exception because I didn't actually implement this in any way. Yeah, I get a null pointer exception because I didn't actually implement any of the functionality, but this is just to show you what that structure could look like. And the factory pattern kind of juxtaposes itself around this factory class. And specifically around the factory method. So those are creational design patterns. So in the next video, we're going to talk behavioral design patterns. We're going to look at iterator, strategy, and observer. And how some of them are so useful that Java has actually integrated them into the language itself. So with that, we'll see you next time. Thank you for watching, and take care.